So now let's look at an example where we find volume. We can use triple integrals to help us find volume. So find the volume of the ellipsoid given by 4x squared plus 4y squared plus z squared equals 16. So here, this ellipsoid, maybe what you want to do first is go to some kind of graphing program and graph this ellipsoid, and you'll see that it's centered about the origin. And I'm going to roughly try to sketch something for you. It's going to go up and down like this and around here. And so here, because I have all of my variables x, y, and z are being squared, here it probably doesn't matter the order that we integrate in. And really we're going to use symmetry here. So we're going to use symmetry. And we're going to only consider the portion lying above the first, what do we call, octant. It's kind of like a quadrant, but in 3 dimensions. The first, let's say, octant. So really that's in this region where all 3 variables are greater than or equal to 0. So it's the part that lies above the xy plane. So the first thing we're going to do is take our equation and solve for z. And z will be bounded between, so if I take the square root here, z is positive because we're talking about the first octant. So z is going to be bounded by 0, and the square root of 16 minus 4x squared minus 4y squared. And if you want, you could factor out a 4 out of that and bring it out of the square root, so it'll be a 2. 4 minus x squared minus y squared. And here, if you're looking at the portion in the xy plane, you're looking at 4x squared plus, you're looking at z equals 0, so 4y squared equals 16, which means I'm talking about a radius. If I divide here, radius 2 circle, and I'm looking just at the portion here in this first quadrant. So x is between 0 and 2, y is between 0 and the square root of 4 minus x squared. So now I'm ready to find the volume. So for the first octant, 0 to 2, 0 to square root of 4 minus x squared, and then 0, and then z is bounded between 0 and 2, 4 minus x squared minus y squared. And the order of integration was dz, dy, dx. Now remember, this is the volume in the first octant. There's 8 octants. There's 4 above the xy plane and 4 below. So when we're using symmetry, we're going to multiply by 8 here. And now I'm getting 8 times the integral from 0 to 2, 0 to square root of 4 minus x squared, You integrate, you get z. So then I'm going to bring the 2 out in front, so I'll get 16. The integral from 0 to 2, 0 to the square root, and it's the square root of 4 minus x squared minus y squared. Now, here I'm integrating with respect to y, so this first 4 minus x squared is essentially a constant, and so now you're going to have to use, unfortunately the only way to do this I think is to use trig substitution here. So if you use trig substitution here, you're going to get the integral from 0 to 2. You should get y times the square root of 4 minus x squared minus y squared plus 4 minus x squared, and it'll be arctangent, it's arcsine, or sine inverse of y over the square root of 4 minus x squared from 0 to the square root of 4 minus x squared. So here you're going to get, sorry, there should have been so now this will be this should have been an 8. So now you're going to plug in top bound minus bottom bound. So 0 plus 4 minus x squared arcsine of 1 minus, if I plug in y equals 0, I'll get 0 there. And then sine inverse of 0 is 0. Arcsine of 1 is pi over 2. So here you're going to get 4 pi, and then 4x minus x cubed over 3 from 0 to 2, and it'll be 64 pi over 3. And there's my answer for the volume.